Good day, everyone. Welcome to Mechanical Technology with Mathebula Goodness. So today we are learning about forces found in engineering components. So we will So here is our lesson objectives. So we will define a resultant force, calculate the resultant force, explain equilibrium and equilibrium. Also identify components of forces, resolve forces into X and Y components, and we will explain a triangle of forces. So let's start with resultant force. Let me show resultant force. Okay, we'll start with introduction. So our introduction is like this. Force is a push or a pull acting on an object in engineering. In engineering, forces help us to understand the stability of structure, machine movement, load support, and force ballast. So let's start with resultant force. So a resultant force is a single force that has the same effect as two or more forces acting together. So for example, if two people pushes a box in the same direction, the total push is called a resultant force. So we'll do this example. I will just only explain. So here we have an example that say calculate the magnitude and the direction of resultant force uh, in the triangle of forces. So here we have 50 Newton and 45 Newton. So now, since we have to apply a component forces. Here we have 30 Newton. So here we go. So since here we are about to find a component of forces acting on this 30 Newton. So we have an angle of 45 degrees. So it means we have to calculate an component of X. So if we calculate a component of X, it means we'll have 30, which is our force, cos of So when we calculate the component of X, we have 30 Newton multiplied by cos of 45, which will give us 66,2. Sorry, I'm making a mistake. So when we make sure you calculate well, 30 cos of 45, we have 21. 21,21 Newton. And then we have to come to, okay, so now we calculate the component of y, which is 30 sine of 45. So here it will give us 21,21 Newton. So after finding components of x and y, we have to calculate a sum of vertical forces. So sum of vertical forces, it means we are calculating the sum of forces that are acting on x-axis. And then after calculating sum of x-axis, we have to calculate the forces that are in vertically axis. So it means you will have to add in vertical components, you will have to add 21,21 plus 45,21. And then in other, and then in horizontal, so in horizontal, we have to calculate to add this one x component and this force 45 Newton. And then in vertical, we will have to calculate 40. And since our here our force is going downwards, it means you will have to calculate as 50 minus 21,21, and then you will find our answer. And then to calculate the resulted force, it means you have to use a Pythagoras theorem to find your resulted force, which means you will have to write force of resulted square is equals to force of x of sum of x's squared plus sum of y squared, and then you will introduce square root both sides, and then you will punch your answers of sum of x and sum of y. And then when you calculate direction, you have to, let me show you. So this one is when you calculate, when you are finding your R as a resulted force. So after here, you will substitute the answer that you will get when you calculate a sum of x-axis and a sum of y-axis. So when you calculate a direction, here is the formula to calculate your direction. So when you calculate your direction, it means you will have to use this formula. So now let's go to okay, so now we are going to equilibrium. So an equilibrium is when two or more forces act on a body and the body remain at rest for when sorry. An equilibrium is when two or more forces act on a body and the body remain at rest and forces are in equilibrium. So when a force are at equilibrium, it means a resultant force is equals to zero. So for example of a equilibrium is, let's check, yeah, when a picture is hanging in a wall, it means that picture is not moving. So it means it at equilibrium because there is, because a resultant force, it will still be zero because there is no movement to that picture. So here we are at equilibrium. So an equilibrium is a force acting to the resultant force but acting in an opposite direction. So the purpose of equilibrium is to keep the body at rest, same size, opposite direction. That is what makes an equilibrium possible. So now we'll go to a component of forces. So this thing is not visible. Okay. So the components of forces, a force can be divided into X and Y. This can help us to solve the problem easier. So here we have a horizontally component which is X axis and vertical component which is Y axis. So now we'll go to the example of a component of forces. So here is an, an example. I hope you can see. So an example is say find a horizontal and a vertical component. So to calculate an vertical and a horizontal component. So now we are going to focus to this diagram. So when we talk about a vertical component, we are talking about our y-axis, and horizontal, we are talking about f-axis. So here we have 100 Newton into 30 degrees, which is our angle. So to calculate our horizontal, it means we have our horizontal component, it is x-axis. So it means we have to calculate it like this. X is equals to our force, which is 100. So our x component is 100 cos of 30 degrees. So to calculate our y component, it means we have Y is equals to our force, which is 100. Side of 30 degrees. So after here, you will use your calculator to find your components of X and the component of Y. So now we'll go to the next slides, which is triangle of forces. So a triangle of forces, if three forces form a triangle taken in order that the body is in equilibrium. So the rule of a triangle of forces in triangle close if a triangle closes, it means the forces are balanced. So here is our example of a triangle of forces. So here we have three forces that are in the direction. So when we talk about a triangle of forces, it is balanced. Here you can see that our forces have closed, which means our force is balanced. Here we have this one, this force, which is this one, and here we have this force, which is this one. So it means our triangle of forces is balanced. So here is our activity. So this activity you will do it when you have a time. If you have a problem with this after calculating, you will tell me on the comments. So this activity say calculate the magnitude and the direction of a resultant force. So I will expect you to check if you have understand the lesson. So here, in conclusion, today we have learned about resultant force, how to calculate a resultant force. We have learned about equilibrium component of forces, and how to calculate the component of forces. We have learned about a triangle of forces. So next time in our lesson when we meet, we will start with a bonds notation. So thank you for watching. Bye.